Okay, so we're looking at what is a turning point. So let's look at a few graphs. I'm just going to draw a few. So a turning point is just where the graph changes from increasing to decreasing. So it's going to be where your extrema are, your max or your min. So this is actually going to be some form of cubic x to the third. I kind of like to look at, if I'm following the graph, this is one piece, and then it changes to a second piece, and then finally a third piece. And so I know it's going to have like x to the third in it. It could have like 2x to the third minus 3x squared, but it's going to have that x to the third as part of the graph. But notice when it's x to the third, I had 2 turning points. So when it's x to the third power, you can have at most 2 turning points. Now what about, think about just a basic parabola. How many turning points do we have? 1. So this is an x to the second. It has 1 turning point. I could draw something a little bit more complicated. And let's talk about how many turning points we have. We have 1, 2, 3. And remember, a turning point is just when the graph changes from increasing to decreasing, or vice versa, from decreasing to increasing. So since I have 3 turning points, this is going to represent an x to the fourth. Now, of course, it could be something like 3x to the fourth minus 4x to the third plus 6. But I know that it's going to deal with an x to the fourth. It's going to be a quartic function. So if a function is a degree of 7, meaning it has something like x to the 7th in it, the graph will have at most 6 turning points. So it's 1 less than the degree. And then if a function is a degree of n, meaning like say we have x to the nth power, so it could be the 10th power, it could be the 100th power, it could be the 1000th power, then it can have at most 1 less than that degree. So it could have n minus 1 turning points. So whatever it is, if it's x to the 100th, it could have 99 turning points at most.